Everyone, welcome. This is lecture number 16 of statics, right? So we are in the process of solving the problems based on catenary. So if you haven't watched the last 15 lectures, you please watch all those and come back to this video, right? Yes. So we have been solving some problems based on catenary, additional constraint that the mass connected with the string, right? Yes. So in this video, we will solve 22nd problem, right? 22nd problem and third problem are somewhat similar, right? Yes. So before that, what I will do is I'll tell you the upcoming course on Unacademy. So as you can see, Unacademy has produced 7 rankers in top 20, 15 rankers in top 50, and 170 plus Unacademy learners have cracked it. And you're going to get one subscription to crack it all, right? 25% off with optional plus 10% using my referral code Prasanna10. So overall, you're going to have 35% offer for GS plus optional, and you're also going to get this S series for free if you purchase 1 year course, and also there is a 3 month festive combo. You're going to get 20% off for optional, 10% plus 10% if you use my code Prasanna10, right? Yes. And there is a new batch starting on 21, 22, 23 aspirants on 20th October, and this is the schedule for 1 year batch. These are the educators, and this is the schedule for 2 year batch, and these are the educators, and there is also a scholarship test, right, on October 17th, and there's also a live mentoring program, and you can also avail loan if you want, right? So you can use my code Prasanna10 for 10% extra additional off, right? Yes, thank you. We will move on to the problem now. So A and B are 2 points, same horizontal line, distant 2A apart, right? AO and OB are two equal ABs tied together at O and carrying a weight at O, right? So what we have here is, so we have 2 points at distance 2A apart, right? Distance apart from these 2 points is 2A, right? The point is 2, right? So see, A and B are 2 points, the same horizontal line, that is same horizontal line of distance 2A apart. AO and OB are two equal tied together at O, right? So we have a point O, right? We have a point O. At O, we are having two string, right? AO and OB are two equal AB string, right? Two equal AB string. So we are tying a two equal AB. Another, we have a point O. So from O, we are tying a string AO, and we are tying another string OB, right? Both are equal length, right? Both are of equal AB string. If L is the length of each, right? So the length of each string is L. So that means this is L, this is L, and overall it will be 2L, right? So the distance between A, 2A apart. So 2A apart, and you can see L is the length of each string. D is the depth of O below the catenary, right? D is the depth of O below the catenary. So that the parameter C of the catenary, which either string angst is given by, we need to prove L square minus D square is equal to cos H A by C minus, right? Before that, what I will do, I will just complete the diagram and then explain once. So we will have an axis here, have an axis around here, right? And we will have a directrix, right? We will have directrix around here. Now you can see L is the length of each, and you can see yes, AO and OB are two equal AB strings tied together at O and carrying a weight at O, right? At O it carries some weight. So let us say it at O it carries some weight, right? So they haven't mentioned the symbol for this weight. Let us assume that it is W, right? So at O it carries a weight W, right? At O it carries a weight W. That means at O, if it carries a weight W, means what will happen? My catenary will be like this, right? My new catenary will be like this. Sir, no? Yeah, watched all the previous problem, then it will be easy for you to follow, right? So my new catenary, and you can see that L is the length of each string. D is the depth of O below the catenary. They have given depth of O, right? They have given this D, right? That is from ear to ear, the distance is D, right? Yes. We need to show that L square minus D square is equal to 2 cos H A by C minus 1. This is what we need to, right? So, what we will have is, so if you want to complete, let me complete the diagram first. So, we will have, and okay, let this length be L. So, we will, this portion of catenary is this portion of catenary is after attaching a weight W at O, right? So, let this distance S, let this S, so let this point be, right? Yes. Now, this is somewhat, diagram is similar for all the problems that we did, right? 21st problem, 22nd problem, 21st problem also you can see we are drawing a same diagram, right? We are drawing a same diagram only. Don't get confused. So, all these problems are having a special condition that a weight W is attached to string, right? Yes. So, we will continue our problem. Problem 20. So, there will be two tensions, one at A and one at E. Let's draw that, right? Let this angle be, let's say this psi A, right? And also there will be another tension at E, right? So let this angle be, right? Yes. Now what we need to show is, we need to show L square minus square is equal to where cos H is 1, right? So what we need to show is, what we need, so what we need to show is, we need to show, what we need to show is L square minus D square equal to 2 times C square cos H by cos H A by C minus what we need to, right? Yes. Now for proving this, what I'm going to do is, first I'm going to find the value of L and I'm going to find the value of D. After finding those, I'm going to square it and I'm going to subtract it, right? Yes. So for that, what I'm going to do is, so you can, here we have cos H, right? So in which relation we will have cos H? Which relation we have cos H, right? So what is the relation between Y and X? Y and X, that is, what is the Cartesian equation of catenary? It is Y is equal to C times cos H X by C. So in that equation we have cos H term, right? Yes. So I'm going to use that now. So we know that Y is equal to C times cos H X by C, right? Cos H X by C, mark this as equation number 1. Basic Cartesian equation of catenary, right? Yes. Now you can see, let us assume the distance from O to this directrix is Y, right? Let us assume this as Y. And what will be the distance from Y to directrix? Will be Y plus D. So no, Y plus D, right? So from ear to ear it is Y, and from O to this point it is D. So overall from A to directrix will be Y plus D, right? Yes. Now I'm going to apply this relation at point E and at point A, right? So at E, I apply this relation at E. So at E, what is Y? Y is equal to Y, right? Yes. Now let us mark the remaining two coordinates also. So let us assume this is X comma Y, right? That is, the distance here is Y as we assume, and let us assume this distance is X, right? Let us assume coordinate E coordinate is X comma Y. Then what this coordinate is? So this coordinate is, so Y is Y plus D here. What is X coordinate for this term? So the X coordinate term is, already here we have A, right? Already here we have A. Here we have A, and here we have one X. So X plus A, right? So my X coordinate is plus A and my Y coordinate is Y plus D. Sir, no? So you can see X is from year to year there is one X, and from year to year there is one X. So it will be X plus is the coordinate for X coordinate, and Y coordinate is very easy, right? So from year to year it is D, Here it is y, so it is y plus. So if e comma y, then a x plus or y plus d, right? Yes. Now at e, what is y? Y is y, x is x, right? At e, y is y, x is x. So if I apply this relation, what you will have? I apply this relation at e, y, sorry. So at e, my y is y and x is x, right? My y is y and x is x and my x is x, right? So if I apply this relation, we will have the same equation, right? Y is equal to c times cos h x by c, right? So mark this as equation number 1, right? Test this, we don't have equation. Okay. Now at a, what will be this relation? At a, what is y? What is y? Y is y plus d, right? Y is y plus d, and what is x? X is x plus a, right? Y is y plus d, x is x plus a. So what will be this equation now? Y is equal to c times cos h x by c will now be this now will be equal to y plus d is equal to c times cos h x plus a by c, right? Mark this as equation number 1. Now I'm going to subtract 2 minus 1, right? I'm going to subtract 2 minus 1. So subtract 2 minus 1, what you will have? 2 minus 1 will, so 2 in the left hand side of 2 we will have y plus d minus, so here we have y will be equal to, now if I subtract these two equations, I can take c common here. If I take c common, we will have cos h of x plus a by c minus cos h of x by c, right? Cos h of x by c, right? Now I can cancel these two terms, so I have found y d now, right? So my d is c times cos h of x plus a by c minus cos h of x by c, right? So mark this as equation number, let us mark this as equation number star, right? So what we're going to, so I have found d now. Now I'm going to find L, right? How I find d? So I have found d by using the relation y is equal to c times cos hx by c, and at e I have used this relation, and at a I have used this relation, right? Yes. So we will find L, right? So to find L, what is the relation between uh, what is the relation between s and x? S and x, right? So what is this relation? What's the relation between s and x? So we know the relation between s and x is s is equal to times sine of x by c, right? A very elementary. I'm saying this often, right? Just have to remember this relation, right? And see relation between s and x is s is equal to c times sine hx by c, right? Now I'm going to apply this relation I'm going to apply this relation at both the points, right? So that is, I'm going to apply this relation at e and at a. So what will happen is, so at e, what is s? S is s, right? At e, my s is s. What is s? S is the length from lowest point to that point. I also know it is equal to s, right? So at e, my s is s and x is same as x, right? So x is same as x. So my equation will be y is equal to c times sine h of x by c, right? Mark this as equation number 3, right? Yes. Now at a, what is my s now? At a, what is my s now? So at a, my s is the length from lowest point to a. So from here to here it is s, and from here to here it is L, right? So it will be s plus L, right? At a, my length of the string is s plus L. S is the length from lowest point to this point. So from here to here, So it is s plus l, right? And what is x? X is x plus a, right? So at a, my x is from here to it is x, and from here to it is a, so it will be x plus a, right? So at a, my s is s plus l, my s is s plus l, and my x is x plus a, right? So this equation will be now s plus l is equal to c times sin h of x plus a by c, x plus a by c. Mark this as equation number 4. You subtract 4 minus 3, right? You subtract 4 minus 3. So this will be s plus l minus s is equal to c times. So I can take c common here, right? Take c common here. It will be sin h of plus a by c minus sin h of x by c, right? So I'm just subtracting these two equations. Now these two will get cancelled. We have L to be equal to c times sin h of x plus a by c plus sin h of x by c, right? So I have found s and l and d now. Now you square it and subtract it. You have to prove that it is equal to 2c square cos h a 1, right? Very easy problem. So how I found d? So I have found d by applying this relation at E and at A, and to find L, applied the relation S and X at E and A, right? Now, what is L square minus D square? So L square minus D square, right? So my L square will be here. Now we need to square this term, right? So sin h of x plus a by c, x plus a by c minus plus sin h of x by c whole square minus, so d square is again c square of cos h x plus a by c minus cos h x by c whole square, right? This is what the values of d, right? Cos h x by a by c, cos h x by c. Now you just need to simplify this, and you need to prove that this term is equal to what? Term is equal to L square minus d square is equal to 2c square cos h, right? Yes. Now you just can take c square common now from these two terms. Just expand in a minus b whole square formula. So it will be a square plus b square minus 2 times ab, right? Times of x plus a by c of x by c, right? Sin of x by c of x by c. And again I'm just taking minus inside. So a minus b whole square formula. So it will be a square. So here we have minus outside. So it will be cos h square x plus a by c plus b square, where you have minus outside, be cos h square x by c minus 2ab. So here we have minus outside, so it will be plus 2 times a. So cos h x plus a by c cos h by c, right? Yes. Now you just, we know that cos h square x minus sin h square x, it is equal to 1, right? It is a basic geometric hyperbolic identity. So sin square theta plus cos square theta is 1, and similarly cos h square x minus sin h square x is equal to 1, right? But here we have sin h square x minus cos h square x, right? So that means from here, so I can write this as minus sin, okay. So sin h square x, this implies sin h square x minus cos h square x will be equal to minus 1, right? If you want, I can also write this in a separate Here itself I will write this neatly. So we know that cos h square x, right, cos h square x minus sin h square x is equal to 1, right? Cos h square x minus sin h square x is equal to 1. This implies, if I subtract this with minus, multiply this with minus, so sin h square x minus cos h square x is equal to minus 1, right? Now can I apply this here? Sin h square x minus cos h square x, sin h square x minus cos h square x, right? So both the term will be minus 1, right? Sin h square, instead of x we have x plus a here. Here instead of x we have x by c, right? So if I apply this result, this will be equal to c square, right? C square will be equal to c square square. Here we have sin h square x minus cos h square x is minus 1. Sin h square x minus cos x square is minus 1. Here I'm going to take 2 outside, right? I'm going to take 2 common. If I take 2 common here, we'll have cos h x plus a, cos h plus a by c, cos h by c. And if I take 2 common here, we will have minus sin h x plus a by c, sin h x by c, right? Yes. Now this will be c square, so the minus 2 plus 2 times. Now this is cos a, cos ha, cos h b, sin h a, sin h b, right? So cos a, cos b minus sin a, sin b is cos a minus b. So here you have cos h, right? So it will be cos h of a minus b. So it will be x plus a minus x divided by c, right? Cos a, cos b minus sin a, sin b, cos a b, right? Cos equal to, if we take 2 common here, so 2c square, 2c square minus 1 plus cos h of, so these two will get cancelled, cos h of a by c, right? This is what we need to prove, equal to 2c square cos h of by c 1, right? What we need to prove. L square minus d square is 2c square cos h of a, right? Very, very easy problem. So I'm applying two relations at E and A. I'm finding L and D. After that I'm squaring and subtracting, right? So very, very easy, right? The next video we will solve 23rd problem, right? Yes, thank you.